Hello, my people, my people. How on a day? Um, um, Last time, so I remember, I don't tell on. I say this time now we will continue with a new series. We will continue with new classes, and for the sake of numbering, because other classes, plenty classes, they where we don't enter. So as we do for the other time, this time sef we will still dey maintain that code wey we use call that class, and the code wey we get we say na MTH 102, and the name na calculus. Na so we talk about for the other time. Now for this class now, I will only try to continue from where we been stop before. Even I fit remember, I tell una say we go do plenty things wey go enable us, wey go make us learn things about function. And we say function na im be the bed, na im be the foundation, na im dey for ground, na im be the basis wey we go fit learn differentiation and integration very well. Say for you to learn differentiation and integration very well, wey be calculus, say we go learn wetin dem dey call function, we go know wetin e be. And for the other class, we don already tell una wetin that thing be. Now before the other class end, if una remember, I been give una some relations, some mathematical formula, some mathematics dem, I write them for the board. I say make una go, when una go, make una try to see whether those mathematics dem wey I give una, wey we dey call relation, say whether those relations na functions. And I don already teach una how to know if something na function or not. And before we close, you remember, we say every function na relation, but every relation no be function. So those relations wey I give una, make una go look whether dem be function. I been give una something like that. Then if dem be function, whether which type of mapping dem be, the way dem dey use mingle, the way dem dey use associate, wey dem dey say map, how dem be, whether injective mapping dem be, or surjective or bijective. I say make una find that one. Then make una also try to plot graph to see, so that we will know the shape of the graph. I been given that kind of work. I don't know how many of una don do am. Now make we do small revision whether una really get wetin I tell una to do. If una remember before I close, I been don do one wey be straight line graph. Then those ones I give una, make we try to see whether if we plot them, how dem go be. Now one of them na one of the examples wey I been give una. Now one of the examples wey I been give una na the function be f of x. Now x raised to power 2 plus 1. This one we even solve am, but I no plot graph. Now you make our plot graph for this one, where we say x they takes value from -2 to +2, this kind of thing. And if I remember, anytime we don't get this one are the domain values that we don't learn. So now for us to determine, to find the range value them, how those ones will be. Then, if not so, the way we do now, we will write x here, we will draw one line here, this one we will put it like this, then this side we get f of x will be this one. This one are the machine, this one are the mathematics, so this will take this value then inside, then we will know which need to go bring out, which will be the output, where we say that the range values. So here now we get x raised to power 2 plus 1, x raised to power 2 plus 1. Now with this one where we get, the domain value then where we get here now already 2 minus 1, 0, 1, and 2. This kind of thing now we get. Then we can draw line like this, make a cross hand. We draw line, make a cross hand, as we've been do for the other one too. Then this one last, this one can be like this. Then wetin dis one mean be say for inside here you know say x dey here. Now when this f of x, this x now take this value minus 2, wetin go happen? Meaning anywhere we see x we go dey put minus 2. Then make we do am like that. Meaning f minus 2 as e dey here is equal to this one sef x dey. So we say anywhere we see x make we put minus 2. So we don put minus 2 but raised to power 2 plus 1. Now this one means minus 2 times minus 2. And minus 2 times minus 2 na positive 4. 4. So we get 4 plus this 1 wey dey. And if you add them together, you go come get 5. Now this other side, the way we do here, we go write the f, then if x takes minus 1, wetin go come happen? Anywhere you see x put minus 1, na the thing wey we dey do. Now this one means minus 1 times minus 1. That one will give you positive 1. But you know say this one dey for this side again, plus 1 again. So if we add this 1 and this other one, we will get 2. Na so e be. Now for this one, when x be 0, wetin go come happen? When x be 0, so anywhere you see x, you put 0. Na the thing wey we don do. The way this one dey na so we dey use right hand. Then 0 times 0 na 0. So this one go be 0, then plus this 1 wey dey here. So that the remaining answer na 1. This one then na the range values, so na the output. When this one don take x values, say e dey output value, na so function be. So this one now, when f don take 1, when x don take 1, wetin go come happen? Meaning we go come write am like this. Then 1 times 1 go give you 1 plus this 1 again, so that we go get 2. Na so e be. Then last we go get when x dey take 2. Meaning anywhere you see x, you put 2, so that here go be 2 again raised to power 2 plus 1. But remember, 2 times 2, we don get 4. Then plus this one. So last we go come get 5. So this kind of thing, if una look am, you go see say this one give birth to this one give birth to this one give birth to this. This one that give birth to this one, this one and this one have also look the same. Now make we try to do am like the pair, that one wey we dey write the rule, go come circle am. That one looks so that the thing go dey clear for us. Already we don do am before. I just dey do am so that we go get understanding for the thing before I plot the graph. Now wetin I dey try to read now, say this one we say na the domain values dem. The domain value dem. Those ones na minus 2, minus 1, 0, 1, and 2. Na the thing dem wey we get for this other side. Now for the range values dem, we get 5, 2, 1. 2, 5 again. But already we don get 2 and 5, so I no go write am again. Because for this mathematics, with this one wey we dey do, e no good to dey repeat something wey you don write. So this one na so e go be. This one na the range value. So wetin we do be say, when e be minus 2, the answer na this one. When e be minus 1, the answer na this one. When e be 0, the answer na this one. When e be 1, the answer na still 2. But 2 we get am here, so this one na go do like this. Then when e be 2, e be 5. Na so e be. So this one wey we get here now, with the question wey we get now, this one na function e be. This relation wey dey here na function e be. Yes, na function. Na function because all these domain value dem wey dey for this side, you see say all of them point out only one time. And you say for it to be function, say this domain side, all of them go point out one time to this other side, range value. So the thing na function. So this one now we fit say that this is a function. Say this one na function. This one na function. Now, which type of mapping, which type of mingling, which type of association will this one come be? Now, if you look this side, we don't say if these ones they wait for this domain side come to one, this one come to one, this one come to one, different ones. Say that one are injective. Now, but if the thing come in a way, say all the ones waiting for this domain range side, all of them, something touch them. But they one like this one, and you see, say this one and this one, they point to this one. This one no be injective, no be one-to-one again. But the condition for the other one will be subjective now. Say everything will be inside, something go must touch them. And if you look, something points to all of them. So meaning that this one will be injective, no be one-to-one. But this one na subjective. This one na subjective mapping. This one now, so it be. Now let's try to, the next thing I want to do now, let's try to plot the graph of this one to see how the thing go be. Let's try to plot the graph of this one to see how the thing go be. If we want plot the graph of this one, say we do like this. For this x side will be the domain side. For the domain side, wetin we get? The highest number wey we get na 2. The smallest number wey we get na -2. So meaning that from here to here, and if we say na 1, here na 2, here na 3, we don cover am. Here and here say -1, here and here say -2, here and here say -3. We don cover this domain side. Now for this range side, if you look, the biggest number na 5, and the smallest number na 1. So how we go come do? So if you say from here to here na 1, from here to here na 2, from here to here na 3, from here to here na 4, from here to here na 5, so you be. Then we don't get a minus for this side though. If not, we forget for this side will be -1, this one will be -2. That's so it for go. Now maybe we try to plot and see whether we see how the graph, the shape, how it will come be. This one how it will be. Now when it be -1, when it be -2, you see say wetin it give out na, wetin it bring out na 5. When it be -2, wetin it bring out na 5 for here. So 5 come here, you did this line somewhere here. So if you come -2, you go get am. If you go 5, you go get am. Now when it be -1, wetin it come give you? It come give you 2. When it be -1, wetin it come give you? It come give you 2. So meaning 2 somewhere here. So if you come like this, you go get the 2. If you come here, you go get the -1. So when it come be 0, wetin it come give you? 1. When the x be 0, wetin it come give you? It come give you 1. So somewhere here, na there it dey. Then Then when it be 1, wetin come give you? It come give you 2 again. That's what it did. When it be 1, it give you 2. So when it be 1, it give you 2 again. So here and here now. So this one said, so that if you come here, get the 1. If you come here, get the 2. Then when it be 2 here, it come give you 5. When it be 2 here, it come give you 5. 5 for here. Like this. So that when you come here, you go get the 5. When you come here, you go get the 2. Now, how this graph dey? Now, if you look, if you join all this one, now this one, they call am line of best fit. If you see am now so this function come be. Now, this function wey we get now as a result of f of x will be equal to x squared plus 1, where the x values dey inside dey within this range. This one na give us this one. Notice this one na the range side will be f of x. This one na the range side. Now he give us this function. You see the shape of this one. This one na so e be. Now make we consider other ones then wey I been give una. Other ones then wey I been give una to see how the shape go be. First of all, we go know whether the thing na function. If na function, whether the thing dey bijective or subjective or e dey injective. When we don do that one, we go know the shape of the function. Now make we try another one. Make I comot this one wey dey for here. Make I comot this one wey dey for here. Now if I comot this one wey dey for here, the example wey we wan look at na say make f of x come be x raised to power 3. Make f of x be x raised to power 3. Where this time now, the domain values then now minus 3 to 3. Now this one way I don't give you already, you don't get the domain values then. So sharply we will draw our line then, try to see how the thing they be. And so we go look. Now x here now will be the domain value we know there. So the next one we want to do now for us to know what be the range value. This side now so they used to write now. This side now the relation now we go write for here. This one now the relation now we go write for here. Will be x raised to power 3 now in the here. So but you know say the domain value them now minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now here we get. As we they do, we go always the rule line so that we go write the other side and inside. Now, when meaning this one, when you want to do now, when x take minus 3, waiting happen to this other side. Now we won't do so. As we don't do before, when x takes minus 3, waiting happen here. So this one will be minus 3 raised to power 3. So that this one will be minus 3 times minus 3. That one will give you 9. Now that 9 times minus 3 again will give you, that 9 times minus 3 again will give you minus 27. This one will give you minus 27. Now if we rule this line again, make the thing know the two mix up. Make it not to join. If we rule this one now x, if you take minus x, if you take minus if you take minus 2, wetin come happen? If you take minus 2, you will see say this one will come put minus 2 raised to power 3. Meaning minus 2 times minus 2, that one will give you positive 4. Positive 4 times minus 2 again will give you minus 8. Now so we get for here. Make I rule this line again too, so that you know we join. F, so anywhere we see x, now with the 2 minus 1 now, minus 1. So that here will be minus 1 raised to power 3. If we do this one, minus 1 times minus 1 will give you 1. That 1 times minus 1 again will give you minus 1. Now this one now, 0. When x takes 0, waiting happen? 0 raised to power 3, everything will be 0. Then when you take 1, waiting can happen? When x takes 1, waiting can happen? We have 1 raised to power 3. And the answer will be 1. 1 times 1 now 1 times 1 now 1. Now if x takes 2, waiting can happen? If x takes 2, waiting can happen? We have 2 raised to power 3. So that we get 32 times 2 now 4 times 2 again now 8. Now here we get. Last, we can't get 3 again. So if x takes 3, waiting can happen? Meaning we will get 3 here raised to power 3. So that 3 times 3 will give you 9, times 3 again will give you 27. This one 9 we get. Now if I look this one, this one come here, this one come here, all of them stand on their own. Make I put them for the other way so that I go understand what we dey do. This one na the domain, make I don't forget. This one na the domain. The domain na minus 3, we get minus 2, minus 1, 0, 1, 2, and 3. This one are the domain. The domain value them, the number them. This one where I want right now the range. Now the range, after when they put this x them, the first thing now minus 27. The other one now minus 8. The other one now minus 1. The other one now 0. The other one now 1. The other one now 8. The other one now 27. This other side now the range values them. The output value. So this one give back to this one. As a result of this one come out. Because 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 of this one come out. And because of this one come out. Now this one now, first of all, this thing na function it be? Yes, this thing na function. This thing na function it be? Yes, na function it be, because all these domain value wey dey for this side, all of them go out one time. This one go out one time, e no go 2 times. If you go 2 times, then the thing no be function. But for this one, this relation na function, because the thing go out one time. The thing go out one time. So the thing na function. Now, which type of mingling will the thing come be? Which type of mapping will the thing come be? or association wey the thing come be. You see say this one come to this one, another one no go to am. This one get im own, this one get im own. All of them get their own. Meaning this one get one to one. So if we say this one dey injective, and also remember for the other one, you say if something go dey subjective, or if all the range this other side, this range value dem, if all of them something touch dem, say the thing na subjective. Meaning say if that thing dey injective and that same thing still dey subjective, say the thing na bijective. So this relation wey dey here na bijective mapping na im dey here. Bijective. This one na bijective na im we get. Now if na bijective, make we come try to know the shape of this function wey we don get, how e go be, the shape of this function, how e go be. Make we try to get the shape of the function. This one we have said is a bijective mapping. Now make we now see the shape of the function. Remember this one we have said is a function. It is a function and is bijective. Bijective. Now, make we see the shape of the function. The highest number, you see say you get negative side and you get positive side for all. So make we put them for center here so that we go fit get the negative side and the positive side. So here na 0, so here go be -1, here go be -2, here go be -3, here go be -4. This side go be 1, this side go be 2, this side go be 3, this side go be 4. Now for this side, make we say we take 10, 10. This one na, make we say we take 10, 10. This one go be 10, this one go be 20, this one go be 30. Then this other side too, this one go be 10, but na minus. This one go be -20, this one go be -30. Now if the thing dey like this, make we try to plot the graph to see how e go look like. Now see wetin e be. When e be -3, e give you -27. When e be -3, e give you -27. 27 go dey close to, -27 go dey close to this 30 here. So somewhere here to this -3 here. Now im we need. Then when e be -2, wetin be the answer? Na -8. When e be -2, e be -8. -8 dey somewhere here. -8 dey somewhere here. -8 dey somewhere there. Then when e be -1, e be also -1. When e be -1, e be also -1. So somewhere here. When e be -1, e be, when x be -1, when x be -1 here, this one sef na -1. So somewhere here. Somewhere here, na im be -1. Then when x be 0, this one sef na 0. This one na 0. When e be 1, e be 1. When e be 2, e be 8. When e be 3, e be 26. So when e be 1, when e be 1, e be 1 here too. E be 1 here too. When e be 2, e be 8. When e be 2, e be 8. When e be 3, e be 27. When e be 3, e be 27. 27 go dey somewhere here. So if you look this graph now, they go like this. Na graph wey no too dey straight. Im dey like snake go. This one na the graph wey we get. Even I use on a graph sheet, then you go see how the thing really dey. This one na as a result of this function na f of x is equal to x raised over 3, where x is in this domain. This one na we get. Notice this one na the range values dem, wey we say na f of x, whereas this one na the domain values dem. And the thing wey we do wey give us this one. Now I get another one. Make we try another one before maybe I go leave am. Make I do another one before I go say I go leave am. This one wey okay make I do two more so that we go really understand wetin we dey try to do. Make I do two more so that we go really understand wetin we dey try to do. Now for this one now, see wetin we wan do now. Make I put 1 over, make I put 1 all over x, 1 all over x. Now if una remember, for the other time I bin give una this kind of domain, but we no go fit take this kind of domain because this kind of domain wey dey means the x go dey take -3, -2, -1 and 0. And if you put 0 for here, e go come make this function undefined. The domain no go fit take number wey go be undefined. The domain no go fit take number wey go be undefined. So we no go fit take this kind of domain. Instead, x go dey like this. -3 go dey less than equal to x less than equal to 1, -1, sorry, -1, union, this one union together plus 1 go dey less than equal to x less than equal to 3. This kind domain na im we go use for this one. This one na im suit am well well, so because this one now 0 no dey inside. Now if this one na im be the domain, as we dey do sharp sharp, make we do the x values dem wey we get now go be wetin? The x values wey we get go be -3, -2, -1. 0 no dey, so we get again 1, 2, 3. Na im we get. Now the function wey we get for this side na f of x is equal to 1 all over x. Meaning anywhere you see x, say make you put this value wey x don take. So first of all, x dey take -3. So f of -3 go be 1 all over -3. And 1 all over -3, the answer go be -0.3333 like that. E go. Now so e go. Now for this other side too, if we say make x take -2, e go be 1 all over -2. And this one go give us -0.5. Na im dey for here. This other one, if we say make f take -1, then we mean -1 here, which is the same thing as -1, So this other one here, if x takes 1 here, mean that 1 over 1, because under na the x or the x value go dey, so na there we go put am. 1 divided by 1 go give us 1. Now this other one wey dey here, if we say make x takes 2, that means we will get 1 all over 2, and the answer will be 0.5. And last, if we say make f take 3, then we will get 1 all over 3, and we will get 0.3333, and so on. So this one wey we get now, which type of, first of all, na function e be? Yes, this one function. This one look like the other one we just do. This one self gets its own unique one, and e dey different from this one. This one self gets its own unique one. This one self gets its own unique one. This one gets its own unique one. This one. So I go say, sir, this one and this one, they look the same. They no be the same. Oh. No say this one na -0.5. This one na +0.5. So they no be the same thing. They no be the same thing at all. So this type of relation na function e be. And which type of association wey e come be? I no need to go the other side, but with your eye when you don look this one based on the explanation wey we don give and other ones wey we don do, you know say this one wey we get na bijective mapping na e be, because this one sef go dey on its own, this one sef we will say if this one dey on its own, all of them mean the thing dey injective. And we say if all these sides sef something touch them, you know say this one now give you this one give this one, this one give this one give this one. If all this side something does and say the thing they subjective, and if the same function they injective, the same time they subjective, say that thing they bijective. So this one wey we get here, say now also a bijective mapping na im we get for here for this one. Now make we try to plot the graph of this one to see how this one will also look, whether e go good for eye or e go follow this snake pattern the way this other one follow. Make we see how e go be. Now if you look this side, you see say negative number dem dey, positive number dey for both domain and this thing. So wetin we dey do now na this kind of thing, make we put am for center so that we go fit get the number dem. The biggest number wey we get for here na 3, the smallest number na minus 3. So this side make we say na 1, 2, 3, 4. Then this one will be minus 1, minus 2, minus 3, then minus 4 for this side. Whereas this side, the biggest number wey we get na 1, and the smallest number wey we get na that. So this one we go get the biggest number na 1. So make we say from here to here na 0.5. Then from here to here say na 1. So the same thing to this one too, minus 0.5. Then here make it be 1, minus 1, make it be minus 1. Make it be minus 1, this kind of graph, so that we will fit plot am. Now first of all, when it be minus 3, wetin e give us? Minus 0.0 something. When it be minus 3, wetin give you minus 0.3? That one go dey somewhere here. So somewhere here, now that one dey. Now, so that if you trace am, e go come, if you trace am, e go come there. When it be minus 2, it go be 0.5. When it be minus 2, it be minus 0.5. Minus 0.5. Minus 0.5 dey somewhere here. When it be minus 1, it give you minus 1. When it be minus 1, it give you minus 1. Minus 1 dey here. Minus 1 also dey for here. Then when it be 1, the other one give you 1. When it be 1, it give you 1 for here. So that's one dey here. When it be 2, it be half. When it be 2, it can give you half for here. When it be 3, it can give you 0.3. So somewhere here. Somewhere here. So this one are the graph wey we get. Now if you try to join all of them, you see say the line dey like this. The line dey like that. This one sef dey like this. This one sef dey like this. This one now because of this function wey we get on all over x, where we say the domain of the function na minus 3 less than equal to x less than equal to minus 1 union 1 less than equal to x less than equal to 3. This domain now na it give us this function. You see the way the thing they use they go. You see the way the thing they use go. Now make we also look another one sharply, sharp. Make we look another one sharp. Make we see the way the thing they use go. This one wey I go give on this one now the absolute value. Make we see how that one be. When f of x be absolute value of this, then the domain can be x dey inside minus 3, 3. Then how it go be? Meaning that this place here now, wetin we get now, x, that's all we get. So make I comot only these ones that we dey for inside here. I will begin to do am one by follow, they go. Now make we do and see. Now, when x takes this one, we get f of minus 3. Means we get absolute value of minus 3. That one will be 3. This absolute value means anything where you put inside, say the thing na positive number. If you put positive number, say na positive number. If na negative, say na positive number. Now the meaning of this absoluteness. So if na so e be, then if you be -2, because of this absoluteness, means the thing go be positive number 2. If x takes -1 again, because of this absoluteness, e go be 1. So if this one take 1, now you say e don even better for am, so that e go make everything 1 positive. If e be 2, then because of this absoluteness, e go make this one 2. If e be 3, because of this absoluteness, e go come make this one 3. So this type of relation, the thing na injective or na such. I mean, first of all, the thing na function. Is it a function? Make we look whether the thing na function or not. If you look, the thing na function because all the things dem wey dey here, dem map out one time, dem map out one time, so the thing na function. Now, which type of association wey the thing come do? Is it bijective or surjective? This one, e dey clear say the thing dey surjective because this one come to this one, and this one also come to this one. All of them. Now, all these are dey come out one time, but e dey go to the same value, two things. So e no be one-to-one, e no dey injective, but rather e dey bijective because all the ones wey dey this side, all of them go dey touch. Make we see am now. Make I do am, make we see. Because some of una now, as I no write am full now, some of una dey do like say we dey do film. Wetin we get here na -3, here na -2, here na 1, here na 1, -1, 2, and 3. Na the thing wey we get. Na the thing wey we get. Sorry, this place now we make small mistake. We no put 0. We forget to put 0 because we just adopt the other one we believe. Because this one wey dey here na 0 dey inside. So if we put 0 for here, wetin we get? Absolute value of 0 is also 0. Na so e dey. Na so e dey. So make we see this one as e go be. So this one here now we say 0 dey here before 1. Na so this one dey. Then the range go be 3, 2, 1, and 0. I no wan repeat these ones again because already we don take them here. We don say we need to write one thing 2 times for this kind of mathematics wey we dey do. So 3 give birth to this one. This 3 sef give birth to this one. 2 give birth to this one. And this 2 sef give birth to this one. 1 give birth to 1. And this one sef give birth to 1. 0 na im come. So you see say all these ones dem go out one time. So make the thing make am function. But this other side now, this one no dey like that one-to-one way. This one go come straight to you. This one now, you see say 2 things dey touch one thing. 2 things dey touch one thing. Na only one na im touch. So but our concern na being say all of them wey dey here, being say as we bin dey talk, being say all this side wey dey here, the thing dem, something touch them, we say that thing na surjective mapping. So this one wey dey here, the thing na this one na function, but the type of mapping na say na surjective mapping. Na im this one be. Now, if we wan plot graph for this one, now make we see how e go be. If we wan really plot graph for this one, make we see how the thing go look like. If we wan plot graph, already this line here na, if here na the center, then know say here na -1, here go be -2, here go be -3. Then this side go be 1, 1, 2, and here na 3. Then for this domain side, we get 0, 1, 2, 3. So 0 we get 1, 2, and 3. So now so it be. So if we want plot graph for this one, you see say when it be -1, the thing give you 3. When it be -1, it give you 3 here. When it be -2, it give you 2. It give you 2. When it be -1, it give you 1. When it be 0, it give you 0. Now, when it be +1, it give you 1. When it be +1, it still give you 1. When it be 2, it give you 2. When it be 3, it give you 3. Meaning, if you dey plot this graph dey like this. This graph dey like this. This graph na because of this function wey we get, wey we call f of x is where x is absolute, and we say the domain na -3, this one now you give birth to this kind of. So you see say different function they give you different shape. The shape of the function them they different. With this one where we don't talk, I know say some of una don't really follow and they understand wetin we dey listen. We don't talk. Now wetin I want do now, this one are the example that we been given at that time. We say make una go solve that. Go look whether the thing na function. If na function, which kind mingling the thing you can use me associate or mapping e do. Then try to plot graph, make we see the shape where the thing go follow. Na the thing we have been tell on at that time. Now after this one, make I teach on one thing. Remember, say all this function wey we dey give una from the beginning, we dey give una the domain already. Now what of in a case where the domain dem no give una, wetin you go come do? In a case where the domain dem no give una, wetin we go come do? Wetin we go come do? All the ones wey we don give una, the domain, we dey give una the function with the relation. Then what of a case where we no give una the domain, wetin go come happen? Meaning say na you go carry your hand find the domain, and the same time you go come find the range. Now make we consider small example to see how the thing really be. Example, say if we consider this one, say this one we call am a function, and the function na like this e dey. If we say another function dey again, where this one na square root of x. If we say another function dey again, where we get 1 all over the square root of 2 minus x plus 5, this kind of function. If we get different types of function dey, but let's say they give you this kind of function. Now, if you look at it, see say I no give you the domain, how you want to find the domain by yourself before you go come find the range? Now, if function then give you function a relation, sorry, if they give you a relation, they no come give you domain, e dey easy to. How you go do? First of all, make we consider this first one, where we say the relation wey we get na x raised to power 2. Now this one, wetin you go do now? You go assume say the domain of this function na the entire real number set. When you say entire real number set, every number wey you know follow. Complex number, no be complex number, but all other number follow. Wey dey inside the real number set, say e follow. Now, your body go also consider, say, but those numbers, they make it be, say, when you put them inside the relation, make it not give you something wey be, go give you undefined, no. Wetin be undefined? Like, if number dey for up, they can't give you something under. Now, if zero come, if this under come be 0, this thing wey they give you so, then they call them undefined. So we don't need that kind of thing. And make you know also think of a number where when you do finish, it will going to give you minus something, minus a number inside square root. This one now will give you I, which one will be complex number. We don't need this type of thing. The other case will be undefined. We don't need this one. And this one, self, we don't need. So if you know come out like this, but it gives you better number, then those ones, now we go take. Now maybe we consider this one as we just talk. Now, we don't assume, as I don't tell you now, we don't assume say the x Now they take x, they take negative infinity to positive infinity. We don't assume. That one will be the exact one, but we don't assume. Make we test and see whether it will work for us. Negative infinity means, like me where they are now, this one at the center. This side na positive, this side na negative. This side go till you no get end. This side go till you no get end. Na it be the meaning. So negative infinity, like this thing the way we dey draw now, here na the center. If you go this side plus 1, 2, 3 till infinity. This side 2, you go negative 1, negative 2, negative 3 till infinity. And this kind of thing. So now we don't take care. So all the numbers, then when they the real number. Now maybe we test them here to see whether those undefined case and complex numbers will come out. Now if we take 0, put for here, you see say we will get 0 square. 0 square na 0. Now if we put negative 1 inside here, we put negative 1 here. You go see say na minus 1 times minus 1. And that one will give you positive number. No be complex number it will give you. It will even give you undefined too. So any number where you put for this side, it will give you number. Meaning this side 0 and this other side, they're very good for us to go. Now, meaning 0 and this other side, they okay. Now, this other side, make we put, if we come put 1, if we come put 1, 1, 2, 1 times 1, now 1. You know, give us an undefined case. You know, also give us complex number. If we can change this one, come put 2. If we can put 3, any number where you take, you see, say, it dey okay. You know, give us undefined, and you know, also give us a complex number. Meaning, this one where we don't take now, this one where we assume, say, it correct, it good for us, for them to be the domain of the function. So this one now, the domain. Now, the next thing, if we don't see this one as the domain, the next thing we want find now for us to find the range. Now we don't say this one as the domain, make we now find the range of the function. Now the range of the function now, when you put 0 inside this one, what will be the answer we will get? Now 0. When we get minus 1 inside this one, minus 1 times minus 1 give you plus 1. If you put minus 2 inside, minus 2 times minus 2 give you plus 4. If you put minus 3 times minus 3 give you plus 9. If you put minus 4 times minus 4 will give you plus 16. So you see, say, the thing they increase from the 0 now, it they increase, but the answer wey they give you no be negative number. All of them are positive number. That one now for this side. Now make we come consider this side will be plus. If you put plus 1 here, 1 times 1 will give you 1. If you put plus 2, it will give you 1, 2 times 2 will give you 4. So you see, say, this side itself, the more they go, it increase too, but na positive number. Means say the range number where we get, this one now is our domain. Now the range number where we get now 0. You see, say when we put them, it no bring negative number at all. It no bring negative number at all. But 0 and you come they increase, they go to infinity. So this one way we get here now, it be our range. If you know one write am like this, you feel write am as this, comma, infinity. So meaning this first one wey dey here no follow. The last thing sef no follow, but na so e dey. Either this one and this one, all of them mean the same thing. All of them mean the same thing. So this one now we don't see, before they don't give us domain, now we find the domain by ourselves, we don't also find the range by ourselves. Now the other one we want to do now the second one, where we get f of x is equal to the square root of x. So make we find the domain and the range by ourselves. Make we find the domain and the range by ourselves. Now, if we want to find the domain and the range by ourselves for this one self we fit do it. This one self we fit do it. How we want use do it? First of all, I don't say when this kind of thing come to you, the first thing wey you think of now to assume say na the entire real number set na im be your domain. If we assume say the entire real number set na im be our domain, means we dey think of something like this. We dey think of something like that. But make sure say no number inside this one go give us undefined case. For this one, e no go give us undefined case because this thing wey dey here no dey like 1/something. E go give us undefined when the under na 0. So undefined case no go dey. But for the complex side, complex thing fit come if we get the square root of a negative number, either -2, -4, negative anything, negative something, negative dey inside square root, say complex number go come out. And we no need complex number. Complex number no dey inside real number. So we no need this kind of thing. So make we test and see. For that of the undefined, we don already say that one no go dey, but this one now no dey in terms of 1/something or something over something. Now this one now, make we now test. Now when e take 0, when this one take 0, we now say square root of 0. The answer na 0. Now if we go this other side, the positive side, square root of 1 go give you 1. If you take square root of 2, e go give you 1 If you take square root of 4, e go give you 2. If you say square root of 9, e go give you 3. So you go see say the more you dey increase the number dey go, the more the answer sef dey increase dey go. In the positive side, e no dey give you complex number. So this side now, 0 and up dey very good. Now make we consider the minus side. Now if we put -1, that thing wey we dey say we no want don come. -1, this one na complex number. If you say square root of -2, because minus dey here, so this one go give us complex number. If you say -3, so all this side wey dey here now go give us complex number, so we no need that kind of thing. So all the minus things dem we no go take am, but from 0 up we go take. So the range, this one here na our domain. Then our domain, so our domain go be no go take this one, because when you don put the negative number dem, you go see say if you put the negative, you go see say the complex number dem dey come out. So the domain inside of this one go come be x, go be, you know say 0 dey inside, then e bin dey increase dey go. It's only this side. Now only this side there, na when you put, you no go give you that negative, but any negative thing wey come, you go give us complex number. So no be this one we go need. So our domain, first of all, we be assume the entire real number. But we don find out say the negative side, if you put am, we go get complex number. So no be that one we need. Instead, this other part na we need for the domain. So this one now becomes our domain. Now for the range, wetin we go come do? Carry this one, put inside, wetin happen? If you carry this one, put inside, you go get 0. If you carry 1, put inside, you get 1. If you carry 2, put inside, you go dey 1 you go dey increase dey go. If you carry 4, put inside, you go get 2. If you carry 9, put inside 3. You go see that you go get 3, 2, 3, 4, 5, dey go. If you get 25, you go get 5. If you get 36, you go get 6. Na so e dey go. The more you dey increase, you dey see say the number sef dey increase. So the range of this function sef go be something like this. The range of the function sef dey exactly like the domain. Either you put am like this, or the domain sef, either you put am like this, or you fit even put am like this. Put am like this, meaning this one no dey, and the meaning this one sef no dey. Now this one too, or you fit put this one -1, comma this. This one and this one wey we get here na the same thing. So this one na him be the domain, and this one na the range for this particular one. Now make we look at the last one before I comot. The last one before maybe we talk about another thing or I comot. The last one wey we get now, f of x is equal to 1 all over the square root of 2 minus x plus 5. This one na the last one we get. Now, I don say make we don't put something here. If we determine the range, the domain, say make we assume say na the entire real number set. So means we dey assume say na x is contained inside this one, negative infinity to positive infinity. We dey assume, we never conclude, we dey assume. Now, but make we look, if we put 0, meaning here 0 dey, if we put 0 inside this one go survive. E go survive. If we put 0, e go survive. But e get number wey dey 2. If we put 2 for here, you go see say 2 minus 2 go make this thing 0. And if you make this thing 0, you go come make the thing undefined. So inside this place, we no need 2. Because 2 go make that thing 0. 2 minus 2 go make this thing 0. And it will be undefined. So we no need 2. Now make we look again. If we come take 3 from 2, if we come take 3, if you put 3 here, you go see say 2 minus 3 go be minus 1. Square root of minus 1 na complex number. So meaning anything wey dey above 2, if you put am here, e go either above 2 go give us complex number. And if you take exactly 2, then it go make the thing undefined. So anything from 2 and above, we no need. Because if you put am, e go either make the system undefined or e go make the thing a complex number. So we no really need that kind, those number there. So wetin we need for this place na from 1, 2 minus 1 will give you 1. From 1 less na we need. So instead of this big one, the domain where we need go be minus infinity to 1. Minus infinity to 1 na we need. Because if you put 1, it will be this. Now, if in case you want write 2, no be this one, I don't say we don't need this one again. Because if you put 2 and the other ones, it will make the thing undefined and a complex number. Either you write it like this, or you say this one, you feel still write them as comma 2, where you put the bracket like this. You see the difference in the bracket. This bracket here and this bracket here, no be the same thing though. But the statement means the same thing. It just be like I carry PIDGIN tell you something, and I can carry correct English tell you for the same thing. Now the same way it mean. The brackets now they different, but the statement wey dey there mean the same thing. Now so this one can be. Now wetin I want una to do, una wey dey lis ten to me, una wey dey for my class, na make una go find this one na the domain. This is the domain. I want make una go find the range. I want make una go find the range. Now, before I come out last, I want tell una something before I come out. Now, sometimes, no be every time wey dem go give una, no be every time wey sometimes dem go give una function wey una go come dey plot graph, go come dey dis thing. Sometimes na only graph you go see. When you see graph, how you go use know whether that graph na function? Make una remember say I don tell una say every function na relation, but no be every relation be function. So when you don see graph, e no mean say that thing go be must function. So when you don see graph, how you go use know say that graph wey dey before you no be function? I wan do something, and that thing I go show una go make una go really see am. And it go sweet on her well. It go sweet on her well. Now, for you to see graph, like example, the first time, you know, say, I been don plot graph like this. Where we say this one na straight line graph, where we will get this one as a result of f of x is equal to 2x plus 1. Now he give us this kind of graph before in our first class, if una fit remember. This straight line now, it get test wey they call vertical line test. It get test wey we dey call vertical line test. That vertical line test means when you don't see graph like this, say make you carry one straight line, put for the graph, then allow making the move in this direction. Now look at this. Let's assume say this one a long stick wey dey. I don put am for the graph. Now, when in dey move, make sure say at every given time, anywhere where the line don reach, make e be say e dey touch the line just in one place. This kind of thing. When it happen like this, anywhere the line reach, anywhere the stick reach, e dey touch this line for one place. When e be like that, say that thing na function. But there are some way maybe when the line dey pass, e no dey touch the, e dey touch the this function wey dem don do for two places. If you dey like that, then say that thing no be function. That thing, that graph no be function. Like this one now, this graph now, if I allow this line to move like this, you see say e dey touch the graph for one place. So we dey say this graph wey dey before us, say na function. Now, you know say we don plot another one wey dey like this. We don plot another one wey dey like this. Make we use the test see whether that thing na function. If we use the vertical line come, you see say e dey touch the line only in one place, in one place, in one place, in one place. So this one sef na function. You know say we bin get another one wey dey like this. We get another one wey we bin do like this. All these ones, when you look, you go see say e dey touch this thing there in just one place. So all these ones na function. But what of if the thing come dey like this? There are some graphs dem wey dey like this. Now, if my stick now long, you see say when you put am here now, you go dey cut here, you go dey cut here too. So in this kind of thing where the line dey cut the graph for 2 or 3 places, that one no be function. This one no be function. If na so, what of this one? If we get something like this, I come give you this type of thing. Is this one a function? If you allow the line pass, you see say e dey touch this graph here only in one place. So this one sef na function. So wetin I dey try to talk be say, with the vertical line test, say we fit know from a graph if the graph na function or not. All wey you go do, all the thing wey you go do na to allow a stick to pass vertical line, allow am to pass through that graph wey dey, whether e dey touch the graph in one place only. If e dey touch the graph in one place only, make you know say the thing na function. But if e dey touch am for 2 places or more than 2 places, make you know say the thing no be function. Now, I thank una well well as una dey lis ten to this video there. Wetin I just want make una dey do now, I want make una dey lis ten to this thing well. Tell una people dem make dem dey lis ten. Now, una wey dey write exam here and there, these things dem wey I dey give una, e no easy o. We dey waste time well well dey do am, so that people no go dey fear mathematics dey run up and down. Na im make we dey do this one. So make una dey tell una people, make una dey watch this video. No be the ones wey una dey go do Facebooking and we know. Make una carry those una data dey learn this thing there. So now we fit explain and give somebody. The person go say, okay, na so the thing be, na so e be. Now, for the sake of this class, we go bang break for here. After now, we go to another one. And as I been dey talk, una go enjoy the things wele dey go. For now, I dey tell una say una bye o.